1.
Good morning everyone. Welcome to the class Easyhai online learning Easyhai. My name is Mahima Agarwal and I am your mathematics educator. So class, in last lecture we were discussing some questions related to the chapter circle, and we have done number of questions and different types of questions as well. So we will discuss some more questions on that topic. Okay, so that you will understand some more concepts related to the chapter circle. Okay class, so let's start. We have completed 7 questions in that series. So today we will start with question number 8. And before coming to the question, I'll give you a simple concept on which this question is related to. Okay, so just listen to me very carefully. It is a simple concept that if there is a circle, just assume that there is a circle with center O, okay, and from any external point, let us assume this is P, a tangent is touching the circle at point Q. Clear? There is a circle with center O, outside point is P, and it's touching the circle at Q. Clear? Now here one chord, basically this is a chord, but when it coming out of the circle, when it is coming out of the circle and touching the point, let assume this is P. Okay, this is P point. So it becomes secant of the circle. This was my tangent because it is not coming inside the circle, and this is my secant, right, because it is cutting the circle at 2 points. Clear? Now there is a relationship between these two lines. If this is my point R and this is T, okay, then the relationship is PQ upon PT is equals to PR upon PQ. Clear? This is PQ upon PT means this tangent upon PT is equals to this complete length of the secant upon PQ, length of tangent. Okay, so indirectly it comes PQ square is equals to PR into PT. Okay, this is what I wanted to tell you about the secant and the tangent, relationship between them. Okay, so this is the concept that we will use in solving this question. Okay, I hope you understand this. So now we will move to the question. So my question is, if from any point on the common chord, there is a common chord RQ, okay, which is touching in both the circles having center O and center C. So if from any point on the common chord of two intersecting circles which are intersecting each other at point R and Q, tangents be drawn to the circle. There are two tangents be drawn. Clear? On the circle with center O, there is a tangent PT, and on the circle with center C, there is a tangent PS. Okay? Now, prove that they are equal. Means we have to prove that PS is equals to PT. We have to prove that both the tangents are equal to each other. Clear? Now we have just seen that what is the ratio between the tangent and the secant. Clear? Is that okay to everyone? Now just look at the diagram. Here we have two circles. One is with center O and the another is with center C. There is a common chord RQ which is improved to point P. Now it becomes secant. It is no more a chord because it has already passed the circle and touching the point outside point P. So So my RP is a secant and PT is a tangent and PS is a tangent as well. It was given in the question that these are the tangents. Clear? So what can we do? Just apply this formula, this relationship in the circle O, in circle with center O, in circle with center O. Okay, whenever look at the circle with center O, what will be the relationship between the secant and the tangent? It will be PT square is equals to PR into PQ. Correct? Just like this, what we have done, the length of tangent square is equals to PR into PQ. This is my equation 1. And now in the circle, with center C, when I took the circle with center C, again tangent square. What is the tangent on the circle with center C? This is PS. Okay, so PS square is equals to, what will be the secant for this? It will be again PR into PQ. So it will be PR into PQ, and this will be my equation 2. Now just compare equation first and second. When I will compare both the equations, the right hand side statement is equal in both the equations, right? PR into PQ, similarly PR into PQ. So what I can conclude from both the equations, that PT square is equals to PS square, and solving it by cutting the squares, it will be equal to PT is equals to PS, which we have to prove in the question. Okay, a simple formula and the simple concept was applied over here related to the tangent and the secant and the ratios between them. If you will not apply this, you will be confused that how can we solve it, how can we prove it that these two tangents are equal to each other. There can be another ways, like by proving the congruency or something else, but this is also, I just took this question just to let you know that this concept is also exist in this chapter. Okay, so this was one of them. I hope you understand. This was the easiest question now. So we will move to the next question now. Okay class, so let's begin my next question. This is a new type of question, so just look at the board carefully. The question is saying a chord PQ. There are 3 chords you can see. One PQ, second QR and RP. Okay, so a chord PQ of a circle is parallel to the tangent. One of the chord PQ is parallel to the tangent MN. Okay, here is one tangent MN. So drawn at the point R of the circle, which is touching the circle at point R. Now prove that R bisect the arc PRQ. We have to prove that this is the arc. Okay, you all know about what is arc. We have to prove this point R is bisect the arc PRQ. Clear? Okay, so for proving that point R is bisecting the arc PRQ, what we have to prove? Basically, we have to prove that angle P is equal to angle Q. And how it can be possible when these two chords are equal to each other? Means it will be a isosceles triangle. In an isosceles triangle, the angles opposite to the equal sides are also equal. Correct? So, how can we prove that this angle, let us assume that this is angle 1 and this is angle 2. How can we prove that these two angles are equal to each other? Okay, so let's think about it and then we will begin. Okay, there is one good statement that PQ of a circle is parallel to the tangent. Okay, so there can be also apply a concept of parallel lines and some angles like alternate interior angles or something. I hope you got the point that if this angle, if I am talking about this one angle, let's take it angle 3. If I am talking about this angle, then this angle is making an alternate interior angle with angle 1, right? So let's write it, that angle MRP, angle MRP will be equal to angle RPQ, angle RPQ. How is it possible? Because PQ is parallel to MN and these two angles are alternate interior angles. Correct? These two are alternate interior angles since PQ is parallel to MN. Correct? So here is, I am breaking it like angle 1 is equals to angle 3. Okay? Statement number 1. If I give it equation number 1. Now another, if I am again talking about this angle 3, then it will be equal to angle 2. If you have remember, in a one segment means the angle formed by the tangent and one chord. Okay, the angle formed by the tangent and the chord is equal to the angle made by the chords in another segment. Clear? So this was the one segment and this was the another segment, right? And this is the angle made by tangent and the chord, and this is the angle made by the chords. So this angle will equal to this angle. Clear? I'll write down the statement. This is angle MRP will equal to angle RQP, angle RQP. Correct? Why? Because angles made by tangent and one chord is equal to the angle made by chords in another segment. Clear? So this you have to remember, that angles made by tangent and one chord is equal to the angle made by chords in another segment. So here angle MRP is the angle which is made by the tangent and the chord, and it will be equal to the angle RQP, which is the angle by the chords in another segment. Clear? So these two angles will be equal to each other. Here I can write them, the angle 3 will equal to angle 2. Okay, this is my statement. Second, now by the first statement and by second statement, what can you conclude? We can conclude by equation 1 and second. What can we conclude? That angle 2 is equals to angle 3, and when angle 2 is equals to, sorry, I should say angle 1 is equal to angle 3. Angle 1 is equal to angle angle 2, I'm sorry, because 3 angle is equal to both the angles. Angle 1 is equals to angle 2 because angle 1 is equals to angle 3 and angle 2 is equals to angle 3. That's why I can say angle 1 is equals to angle 2. So here it is, and when angle 1 is equals to angle 2, then I can say that this R is bisect the arc PRQ. Okay, hence we can say, hence R bisect the arc PRQ. Clear? This you have to prove. I hope this is clear to everyone. You just have to remember this one thing in this question. Okay, this is the new thing, I guess, but keep it in mind that angles made by the tangents and the chord is equal to the angles made by the chords in the another segment. Clear, class? So this is one kind of question in which we have used a new property, and similarly in the last question we used some new property. That's why I am just carrying out these questions, okay, so that you will understand some more properties in this chapter. Clear, class? So I hope you understand this. Now we will make another question, question number 10 of the series. Okay, now class, this is the last question of the series, question number 10. And in this question, the given quantities are given that ABC is a right angle triangle. We are given that ABC is a right angle triangle. Here we have 90-degree angle at B. Now, such that BC is equals to 6 centimeter. Length of BC is given. Okay, what all are is given? BC is equals to 6 centimeter and AB is equals to 8 centimeter. AB is equals to 8 centimeter. So we can say that the base is given because it is a right angle triangle. Though I can say that BC means base is given 6 centimeter and AB means perpendicular is 8 centimeter given. Clear? Find the radius of its incircle. You can see that there is a circle with center O and having radius R. We have to find out that what will be the radius of R when we are given length of the base, which is 6, and length of the perpendicular, which is 8. Okay, so first of all we will find out the length of the hypotenuse because it is the easiest task to do. Okay, so let's find out length of AC. Here, using Pythagoras theorem, AC square will equal to AB square plus BC square. Correct? AC square is equals to AB square means 8 square plus 6 square means this is equals to 64 plus 36. It means is equals to 100. Right? And AC will be 10 centimeter. Clear? No doubt. AC is equals to 10 centimeter. Now I have length of all the sides of the triangle. I am having all the sides of the triangle. Okay. Now just come again that we have to find out R means radius of the circle. We don't have to find out any measurement related to the triangle. So how can we relate it? Okay. Now think about it that this is a circle and these three sides are touching the circle at any individual points. I can see that AP is one tangent and AR is also a tangent from a common external point from point A. So I can say from point A, here we have two tangents, here we have two tangents AP and AR. So these two tangents will be equal to each other. So from point A I can say AP is equals to AR. Okay. From point B Again there are two tangents. From point B, this will be BP is equals to BQ, right? And from point C, there are two tangents again. CR is equal to CQ. CR is equal to CQ, correct? Okay, now just keep them, remember. I mark them as equation 1, 2 and 3. Okay, we have 6 tangents from 3 different points. I mark them as equation 1, 2, 3. Okay, now what can I do? Again come to the point that we have to find out R. Is these useful to us to find out the value of R? How? Just look at this part. If I look at the rectangle POQB, here it is given that this is a 90-degree angle, right? It is given that ABC is a right angle triangle at B. So this is a right angle triangle. Since this is a tangent, then it will also a 90-degree angle. Again, this is again a 90-degree angle. And when 3 angles are 90 degree, the remaining one will also be 90-degree angle. So can I say that POQB is a square, means length of PB and length of BQ will equal, or we can say that the opposite side will also equal, means it is R, then it will also R and it will also R. Clear? Okay, so what can we write? That since all the angles are 90 degree, we can say that POQB is a square. POQB is a square. Clear, class? Okay, now this is the another thing. We are just breaking it to come to the conclusion. Okay, first part is this, that we have find out the length of AC. Second, we just equalize the tangents, that what part of tangent is equal to the what another part. Now this is the third, that this we can say that PQOB is a square. This is the third part. Okay, now come again, we have to find out value of R. And we already know that the length of this is 8 and this base is 6. So can I write AB is equals to AP plus PB, or I can say PB is equals to, I'll write it here, PB is equals to AB minus AP. AB minus AP. What all are the known quantity over here? Length of AB and PB is the radius. So I will write it as AP is equals to AB minus PB. Correct? And AP is what? AB is what? 8 centimeter. And PB is what? PB is R. PB is equal to the radius of the circle. So it is equals to R, means AP is equals to 8 minus R. Okay, let's take it as equation 4. Similarly, in this side, when I will take the side BC, I will see that QC will equal to BC minus BQ. Correct? Now QC is equals to, BC is what? 6 centimeter, it is given, and BQ is what? Is equals to R. Now I can say QC is equals to 6 minus R. This is my equation 5. Okay? Okay. Now just think about it, that here is a tangent AC. So I can write AC is equals to AR plus RC. AR plus RC. Can I write them as AR plus RC? And by equation first, AR is equals to AP. AR is equals to what? AP. AC is equals to AR is equals to AC. And RC is equals to CQ. RC is equals to CQ by equation first and third. Okay, I use the equation first and third. Now AC, value of AC is what? Sorry, it is not AC, it will be AP. Value of AP is what? 8 minus R. So I can write 8 minus R plus value of QC is what? 6 minus R. It will be 6 minus R. Right? And what is the value of AC? We just find out it is 10 centimeter. Correct? Now I can write 10 over here. Now is it easy to solve? 10 is equals to 8 plus 6, 14 minus 2R. Now just take 2R at left hand side and this at right hand side. 14 minus 10, 4. So R is equals to 2. Hence I can say R is equals to 2 centimeter. R is equals to 2 centimeter means radius of the circle will be 2 centimeter. What I have done over here, just look once again. There is a circle which is in circle of the triangle and the triangle is right angle triangle. Okay. So first of all, the length of two sides is given. BC is given and AB is given. So I have to find out the length of the third side using Pythagoras theorem. Length of the third side AC will be 10 centimeter. Okay. First part. Second part, there are tangents. From point A, there are two tangents AP and AR which will be equal, equation 1. From point B, there will be PB and BQ, equation 2. And from point C, CR and CQ, third, means these tangents are equal to each other. Now third, since all the angles are 90-degree angle in this part, in the part POQB. In this part, all the angles are 90-degree. So PQOB is a square. We can say this is a square. And when it is a square, we can say that PB is equals to R as well as BQ is equals to R. Okay. Now next part. When I break the line, this is PB. Can I write PB is equals to AB minus AP? Or AP is equals to AB minus PB? Means I just took this part. I have to find out the value of this part. Means AP is equals to AB minus PB. Similarly, CQ is equals to CB minus QB. Right? And the length of AB and BC is given. So we can directly put the value, and since AP and BQ are equal to R, we just have proved in this part. So we can write AP is equals to 8 minus R and QC is equals to 6. 1. Okay. So I can write AP is equals to 8 minus R and QC is equals to 6 minus R. Okay. Now I have given them equation 4 as well equation 5. Now this is the final part of the question. What I have done, I just break the line AC in two parts, that is AR and RC. And AR by equation 1 is equals to AP and RC by equation 3 is equals to CQ. And we have already find out the value of AP and CQ. So conclude the value, that is 8 minus R plus 6 minus R, which is equals to length of AC, which is 10 centimeter. Okay, which we have find out earlier. It is 10. Now I can find out the value of R easily. There is only one variable, that is R, and one equation. So R is equals to 2. I can write it here. R is equals to 2 centimeter, which was the required question. What is the radius of the circle? Hence, the radius of the circle is 2 centimeter. Clear? So, I hope you understand this question. It was a bit lengthy, but it was the last question of the series. That is why I took this type of question. I hope class you enjoyed the series of every chapter in this in maths. Also you are practicing them at home also, because if you will not practice you will forget everything. To learn anything you have to practice more, and maths always require practice more. Clear class? So this is done for the day. We will continue next chapter in the next lecture. Till then you practice more, learn more and love your mathematics. Thank you.
2, 1.
Good morning everyone. Hello.
2, 1.
Hello everyone. Good morning.
2, 1.
Hello everyone. Good morning. Welcome to the class Easyhai Online Learning Easyhai. My name is Mahima Agarwal and I am your mathematics teacher. So students, in today's class we will learn a new chapter from class 10th. You have already learned about this chapter, that is surface area and volume, in your previous class. The very basic knowledge has been given to you in that class also. But we will discuss some more in this chapter in this class. Is that clear? So I will not take that you have learned anything in your previous class. We will continue with the basic concepts. Okay. So first of all, we will talk about the meaning of the name of the chapter. That what is surface area and what is volume. Do you know what is surface area? Surface area. Basically, name indicates everything, but you should understand the concept also. Let's take a shape. If I take rectangle, okay, this is a rectangle having length L and breadth B. So what will be its surface area? First of all, what is surface? Surface is something that we can see, we can touch or we can utilize, right? If I talk about an area of land, of any shape, it means we can use this area like in anything, like for construction, anything, for farming, for staying there, for anything we can use that area. So what does this mean? How can we limit this area? For limiting this part, we are using dimensions, right? And for dimensions, like if I talk about square or rectangle, we use two dimensions. One is length and another is breadth. Length is something that is it is in any dimensions, like in a smaller case it is centimeter, then in meters, then in kilometers, then in hectares or many things. Okay, so in case of length, it is a length of any one side. Okay, now if I talk about length of any one side, let's take this. So it will be going beyond to this side. It will be going beyond up to some point of, is there any limit? For limiting it, we have another quantity, we called it breadth, so that we can limit this much area up to length and up to breadth. For example, if there is a area of 100 meters square, what it means, its length will be 10 and its breadth will be 10, correct? Now I have to find out a particular part of it. Let's take, if I take 4 meters square, if I have to take only 4 meters square, so what should I do? I have to take length and breadth, and length will be limited to 2 meters and breadth will also be limited to 2 2 meters. Means both the quantities when 2, then it becomes an area of 4 meter square, including both the dimension, and it will be a closed area. I hope this is clear that why we use area. What is the meaning of dimension? Just to limit something. Okay, if we will not find out what will be the length and length or breadth or something or any other dimension, we cannot really conclude it. We cannot really find out what we want to conclude from it. Okay, so it is important, the dimension. There is a importance of dimension. Okay, so this is the surface area. Now let's talk about volume. What is the volume? Volume, basically it is the quantity that is required to fill the container of that particular shape up to that highest point. Okay, let's take a shape that is cylindrical. If I give you an example, if it is a glass, okay, if it is a glass of cylindrical shape, then if I pour water into it, then the quantity of water or quantity of anything, if it is empty, then I can say the quantity of air into it, and if it is filled with anything like by air, by water, by sand, or by anything, so the quantity of that particular thing that can fill its highest surface, it is known as volume of that shape. And it is not possible in 2D figures. It will always possible only and only in 3D figure, having three quantities like length, breadth and height. Okay, so this is the volume. For any shape, the definition of volume will remain same, but formula of volume will be different. Okay, so this is my surface area and this is my volume. I hope you clear it.
1.
Okay class, so after knowing that what is the surface area and what is the volume, now we will come to some particular shapes. In your NCERT syllabus, in your CBSE, there are total 7 shapes in class 10th. That is cube, cuboid, cone, cylinder, sphere, hemisphere, and then frustum of the cone. Okay, frustum of the cone is something new for you, but it is really interesting. Okay, so we will go one by one to all these shapes. So first we will talk about cuboid and cube. Cuboid and cubes. And first I will derive the formula for both the shapes. Then I will discuss some important questions and types of questions that is related to these shapes. Clear? So first of all, how these shapes looks like. Okay, though the appearance is the most important part. How can you find out that this shapes is something? Okay, so you should know how it looks like, what are the dimension, and how do we have to find out the areas, surface areas and volume of the shapes. So let's start. First we will talk about cuboid. Okay, cuboid is a 3D figure. Okay, 3D figure means 3D. 3D means it has 3 dimensions. Okay, it names indicates that this is 3-dimensional figure. And what are these 3 dimensions? That is 1 length, L, second breadth, okay, and third is height. Clear? So there are 3 dimensions: length, breadth and height. Now look at this figure. If you visualize, it is something like a rectangular box which is closed. Okay, so if you imagine a box, here we have 4 faces. Just imagine a room also. You can imagine a room in which you are sitting. Just look at the room. Now you have 4 walls around you and two surfaces at the upside or the downside, means that is floor and the another is ceiling. So here we have 6 surfaces. How many surfaces? 6 surfaces. Okay, surface number 1, 2, 3, 4 and the back one 5 and the front one, that is 6. Okay, can you visualize? You can easily visualize if you are sitting in a room and imagine a room or something, a closed rectangular box. Okay, so you can easily visualize that what kind of surfaces I am talking about. So here we have 6 surfaces. Now edges. What are the edges? If I am sitting in a room, so here corners. If I in a lame language I will say corners. So how many corners are there in your room? Can you count? If you will count the 1, 2, 3, 4, or is there any another corner? Basically 1, 2, 3, 4, 5, 6, 7 and 8. There will be 8 corners. Clear? Understood? Okay. Now let's talk about the lines. If I have to draw this figure, then how many lines I have just drawn? So here 1, 2, 3, 4. Okay. 5, 6, 7, 8, 9, 10. All covered? 11 and 12. There are 12 lines. I'm just telling you everything in just lame language. Just let you understand everything. The language is not important, concept is important. If you will understand that what I'm talking about, that there is 6 surfaces, 8 corners and 12 lines, you can easily understand the figure. Okay. Similarly, in a case of cube, this is a cube. What all the similarity in cube and cuboid? First of all, it is also 3-dimensional, but having only one difference. It has 3 dimensions, but its all dimensions are equal. Its length and its breadth and its height, everything is equal to each other. All the dimensions are equal. Length is equals to height is equals to breadth. Okay. Again, it has 6 surfaces because shapes are alike, but there is only one difference. The length, breadth and height are equal in the case of cube. 6 surfaces, 8 corners and 12 lines. Clear? Eh? I hope this is clear. Now let's talk about the area. When I talk about area, so here we have 6 surfaces, means total surface area. What questions arises, like if you have to paint a room upside down, all the 6 surfaces, then what quantity of paint will be required? This is a kind of question in this chapter. So for this you have to find out area of all the surfaces. Since in cuboid these all surfaces are not equal, that's why total surface area for cuboid would be total surface area of cuboid. It will be, let it is breadth into height. Number 1, b into h plus h into L, means this one surface, h into L, correct? Into L plus L into B, means this one surface, having L into B. And all these surfaces are just twice. All the surfaces are twice. That is why my formula will be 2 LB plus BH plus HL, where L is length, B is breadth and H is height. Okay. Now come to the cube. When I talk about cube and its total surface area means area of all 6 surfaces. Okay. Then in the case, since length, breadth and height all are equal to each other, so I will take it as A. If length and breadth of the height all are equal to A, then I can say area of each surface will be what? A into A, because it is the formula of this square, that is A into A. So area of one surface is A square. For two surfaces it will be 2A square. And here we have 6 surfaces. That is why total surface area of the cube will be 6A square. Clear? So here is the TSA of cube. Easy? Now let's talk about the lateral surface area. What is the lateral surface area? Lateral surface area is, if you are sitting in a room, imagine a room. So if a question is asking that you have to paint only 4 walls of the room, means that surface which is covering you, okay, that is not under your feet and not up to the head, okay, only the 4 surfaces that is covering you, around you, that is the lateral surface area of the cuboid as well as cube. Okay, so in the case you have to find out the area of the 4 surfaces, not 6 surfaces. Okay, so in case of cuboid, lateral surface area, okay, LSA, lateral surface area will be equal to, since it is again we will have 4 surfaces and 2 surfaces will be repeated, that is opposite to each other, so it will be 2 L plus B H. In simple, I can also write 2 L into H plus B into H. I just summarize it and write it as 2 L plus B into H. Clear? So that is lateral surface area of cuboid. Now come to the cube. Again, all the surfaces are equal and we have to find out the area of any 4 surfaces, not any, like the covering 4 surfaces. So the lateral surface area of cube will be 4A square, because area of each surface is A square. I hope this is clear. Now the last quantity is volume. What is volume? As I have told you that volume is something that it is the quantity that can fill the entire space into that particular shape. So volume. In the case of cuboid, the volume will be L into B into H. Okay. When I was talking about the area, it was L into B for 2-dimensional figure. Means that area will be filled. Right? So when I have another quantity, that is height, so obviously it should be filled up to what limit? To find that limit, I have to multiply length to breadth and to height. So the volume of this cuboid will be L into B into H. Okay, and similarly when I am talking about cube, it will be equal to volume when its all quantities, all dimensions are equal, that is A, so we can write A cube, A into A into A. Clear? So here is the formulas of cube and cuboid, and also I have give you the proof what we have derived the formula and what is the logic behind them, what is the meaning of lateral surface area and the total surface area and the volume. Okay, so you should understand these 2 figures entirely in your mind. You can easily imagine them. Okay, so now I will move to the questions related to these chapters, these shapes.
1.
So we have discussed both the shapes, their area, surface area, lateral surface area and the volumes. So now we will discuss and visualize the shape more by discussing some questions that will be very important on the point of view of your exam. Okay, so we will discuss now questions based on these two figures. Okay, then we will discuss some more shapes later on. Clear? So this is it. Now let's come to the questions.